Okay, guys, we've just finished up taking our notes on our rational and irrational numbers. And now we're just going to take this tree map real quick and we're going to put some examples on it. And then I'm going to you're going to put that into your notes. So, rational numbers. Let's just look at some examples of rational numbers. I just want to make sure we're clear on rational numbers. Rational number examples. The first one, percents. So, sorry, I hit my camera with my hat. Percents like 75%, 3.2%. All of any percent is a rational number. Fractions like 1/2, 2/3. I'm sorry, my camera, I keep hitting it with my hat. 2/3, 8/3. That is an improper fraction, but it is still a fraction. 2 1/2. That is a mixed number, but it is still a fraction. All of those are rational numbers. Decimals. Terminating decimals. Remember, terminating decimals are decimals that stop and have no definite, they have no, they stop. They don't have a repeat. They have no remainder. They have 0 remainder. So 0.5, 0.25. And we're going to come back and talk about one more over there in just a minute when we get to it. Repeating decimals. Our repeating decimals. Numbers like 0.3 repeating. 0.625 repeating. Anything that has a repeating bar would be considered rational. Integers. Numbers like -15, +25. Any numbers, positive or negative numbers, are rational. Okay? Also, right down here, we're going to put, I'm going to make you a little copy of this to put on your paper. I'm going to shrink it down a little bit and give you one of these, but we're going to also place our perfect squares on this side because all of our perfect square numbers, all of these numbers are rational, okay? I do want you to just make a note. We're going to put this right over here. I'm going to shrink it down for you. And it's going to kind of fit right there. So I also want you to just make a note of the square root of 64 is rational. The square root of 121 is rational. Okay? You also have your perfect cubes. I want you to circle this because of all of the ones that we are using, 64, yours will be sitting like that, but 64 is also a perfect cube. You need to remember that 64 is also a perfect cube. 64 is 4 to the third power. It's 8 to the second power, 4 to the third power. So it's also a perfect cube. That doesn't look like the word cube, does it? Perfect cube. Okay. I'm going to just move that out of the way. But that's going to glue down. Yours is going to glue down. And when I put mine in Google Classroom, I'll have it glued on there so you can see what it looks like. So now let's talk real quick about irrational. Irrational numbers. Non-terminating, non-repeating decimals. So any decimal number that has a dot, dot, dot at the end. This is what you're looking for right here. If it has that, it is a irrational number. If you see the pi symbol, it is an irrational number. If you see 3.14 dot, 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 it is irrational. But, come back over here a minute. If you were to see 3.14 like this, this is rational. There is no dot, dot, dot at the end, meaning that that is a terminating decimal. What we end up doing when we use pi and use 3.14, it is considered rounded. Once we round this number, once we round it, we have now made it rational. You can make an irrational number rational by making it into a terminating decimal or a fraction. You can round it for it to become rational, but in its truest form, it is irrational. We will round pi to 3.14 so that we can use it in formulas and that kind of thing. And when we round it to 3.14, we make it rational. But pi, 3.14 pi in its truest form is irrational. I had somebody, an adult math teacher, argue me down one day that pi was rational because it's 3.14. It is not rational, but we create a rational number using pi when we round it and make it this decimal number. And what's going to happen on different kinds of tests and things, you're going to see, it's going to say which of the following numbers are rational, and it's going to give you this with nothing behind it. It's just going to give you this. If you see 3.14 like this, that is a rounded version of pi, and it is rational. The only time you would say irrational if you see the pi symbol or if it has those dots at the back of it. Okay? And that is one thing that people who write all these tests and kind of thing, they will throw that one at you in a heartbeat because they know that you know that pi is irrational. And so they throw 3.14 in there and ask you if it's rational or irrational. And your knee-jerk reaction is going to be, oh, pi is irrational. Pi is irrational. But to express it, it's either got to be written like this or like this. If pi is written like this, we have rounded it and turned it into a rational number. Okay? Now, imperfect roots would be things like imperfect square roots, like the square root of 27, or the cube root of 9. Okay? Basically, all of these and all of these are rational. Any numbers outside of these would fall over here. Okay? Any numbers outside of these that you're trying to take the root of would fall over here. They would be irrational. Okay? So, years ago, I had my students draw some conclusions about rational and irrational numbers. And what we concluded was that you don't have to remember all of this. We don't have to think about this. We don't have to remember all this. If you can remember three things, okay? You've got to remember that if you see, let me see, I'm going to get me a little something to highlight. If you see this dot, 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 if you see the pi symbol, or if you have a non-perfect root, okay? Those three things. You look for those. Look for those. And if that doesn't exist, you have a rational number. If you don't have this, you have this. But you don't have to look, you don't have to go in, you don't have to look for all this. If you can just remember these three things. The dot, 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 pi as pi symbol, or non-perfect roots, then everything else is rational. Everything, no matter how weird it might look to you, it is rational. Okay? And we're going to do some practice with that to let you kind of get used to seeing them and looking at them that way. So here this is. I'm going to get these glued on here, and I will get it scanned in to put into Google Classroom for you to continue copying. And we're going to move on to our next activity.